Hi, I'm Will Dangler, and this is the 5th episode of the Art of Math Proof. In our series so far, we've been using the rules and properties of algebra without always explicitly stating what exactly those rules and properties might be. As such, in today's episode, we're going to spend the time to talk about what all these rules and properties that we have been using are, as well as a few that we're going to need in upcoming episodes. The first property we're going to talk about today, the property of closure of addition and closure of multiplication over the set of integers, is one we've already mentioned. This property tells us that for any two integers, x and y, the sum of x and y and the product of x and y are always going to be another integer. Now this is a very important property because it allows us to know that if we're working with addition and multiplication of integers, then we never have to worry about leaving the set of integers. Now the next three properties should all be familiar to you from your elementary school math classes: the commutative, the associative, and the distributive properties. The commutative property tells us that when we're performing addition or performing multiplication, it doesn't matter which order we write down our numbers that we're adding or multiplying together. Explicitly, for any two integers, x and y, we know that x plus y is going to be the same value as y plus x. And similarly, for multiplication, we know that x times y will be the same value as y times x. Now, the next property, the associative property, allows us to reason about what will happen if we're performing multiple operations of addition or multiple operations of multiplication. With addition, the associative property tells us that for any three integers, x, y, and z, the sum of y and z added to x will be the same value as the sum of x and y added to z. Similarly, for multiplication, the associative property tells us that the product of y and z multiplied by x will be the same as the product of x and y multiplied by z. Now our final property from elementary school mathematics, the distributive property, is the property that ties together addition and multiplication. Explicitly, the distributive property tells us for any integer x that the product of x with the sum of the integers y and z is going to be equal to the sum of the products of x and y with the product of x and z. These three properties are very common and should probably be second nature to you at this point in time. Nevertheless, it's important for us to state them explicitly. Moving on to the additive and multiplicative identities. We know that in addition, the number 0 has the very special property that if we add 0 to any integer x, we'll always end up with that integer x. As such, we call 0 the additive identity. Now, the number 1 acts in a very similar way to 0 when it comes to multiplication. In multiplication, the number 1 multiplied by any number x will always produce the number x. And as such, it's referred to as the multiplicative identity. Now before we move on to our next property, we should also note that if we take any integer x and multiply it by 0, we're going to end up with the integer 0. Now the next property we're going to talk about, the additive inverse, is something I'm sure you're familiar with. However, you may not have heard it stated in such a way. So the additive inverse. Well, for every integer x, we know that there exists another integer that will denote minus x that has the special property that x plus minus x is equal to 0. And we call minus x the additive inverse of x. Furthermore, we also know that minus x is going to be equal to -1 times x. We can then use the additive inverse to define subtraction. Explicitly, we define the difference of two integers, x and y, to be equal to the sum of x the additive inverse of y. Now this is a very useful definition of subtraction because it allows us to convert any problem in subtraction into a problem of addition. And then once we're working with addition, we'll be able to use all the properties we know about addition to work on a problem about subtraction. And the final properties of algebra I wanted to talk about today is what happens when we multiply together positive and negative integers. Well, if we multiply together any two positive integers, we know that the resulting product is always going to be a positive integer. Furthermore, that resulting product will always be greater than or equal to either of the two integers that went into that product. Now, if we were to instead multiply together a negative integer and a positive integer, we know that our result will always be a negative integer. Furthermore, the resulting product will always be less than or equal to the negative integer within our product. And finally, if we multiply together two negative integers, we know that the resulting product is always going to be a positive integer. So this concludes the properties of algebra that we have been using and will need in the upcoming episodes. In the next episode, we're going to take the time to prove that an integer cannot be both even and odd at the same time. Until next time, this has been Will Dangler.